Okay, so the video cut off there, but all I did was set this equal to there. You plugged in 2, and then you solved. So when you solve, you get P equals 3. Okay. Now we are on to the very last page. Yay. Okay, so these last two problems are the related rate problems. I would definitely pay attention to these because they are very similar to the ones on the test. So you have a 5-foot ladder sliding down a wall, okay, and we are given at a constant rate of 2 feet per second. So the trick here is that you know you're sliding down the wall, so this 2 feet per second is going to be negative. So writing down your given information, I would say that you are given that the change in y over time is -2, and we want to find the change in x over time when y equals 4. Okay, so you can sketch a picture if it makes you feel better, and it says the ladder is 5 feet, so I can label that. That's the hypotenuse of this triangle. I'm going to call this x and this y. Okay, and the formula that I need to use for this, you're going to use Pythagorean theorem. So you know that x squared plus y squared equals 5 squared is 25. Okay, and we need to take the derivative of that. So remember, with related rates problems, you're taking the derivative with respect to time. So anytime you take the derivative of something and the variable is not a t, you need to adjust it with that implicit differentiation technique. So when I take the derivative over here, I'm going to get 2x dx dt plus 2y dy dt equals 0. Okay, so I have that derivative there, and now I need to get an x value when y is 4, because I'm going to actually try to plug in here, because I'm given this dy dt as a -2, so I've got this. I'm going to have a y value of 4, okay? So let's see, if this was a 4 over here, that would be a 3, 4, 5 triangle. So the x value there is going to be a 3. So when I go to plug in, it'll be 2. I can get a 3 there. Again, I get this 3 because it's a 3, 4, 5 triangle. And dx dt is what I'm trying to figure out, so that's going to stay my variable. Plus 2, my y value is going to be a 4. And my dy dt is a -2. Okay, so I'm plugging that in. That equals 0. And now it's just a matter of cleaning up. So I've got 6 dx dt, and then that's going to be -8 times 2 is -16, minus 16 equals 0. And I'm trying to solve for this dx dt, so add 16 and then divide by 6. So you get dx dt is going to be 16 over 6. If you want to reduce, you could call it 8 over 3. And I'm going to measure that in what, feet? It was in feet per second, so feet per second there. So the distance between the wall and the base of the ladder will be increasing at a rate of 8 over 3 feet per second. Okay, last one. So air is being pumped into a ball that is the shape of that's shaped as a sphere, and this is the rate. How fast is the radius changing? So I'm trying to find the change in radius, okay? And I actually gave you this formula. Keep in mind that these formulas would not be given to you on the AP exam. I gave you the formula here as a kind of a starting point. So again, I always kind of write down what I'm given. Okay, so I'm given the change in volume over time, and it's increasing, so that's going to be 6 cubic feet per minute. And I want, right, I'm trying to find the change in radius over time, and they want it when r equals 3. So I have to have that volume formula. So when you go to use that formula, you need to take the derivative because I want to know how it's changing. So the derivative of this is 1 dv dt, so dv dt equals, when I take the derivative here, you do not, I repeat, you do not need to use the product rule because 4 over 3 and pi are both constants. So you just multiply this 3 by there, that you get 12 over 3 is 4, pi r squared dr dt, because you took the derivative of a variable that was not time. And that's your derivative. Now all you need to do is plug in. So we are given dv dt is 6, so you plug in a 6 there. 4 pi r squared. Well, I've got my r over here, so that's going to be 3 squared. And I'm trying to figure out what dr dt is, so that's my variable. So let's see, I've got 9 times 4 is 36. So I've got 36 pi dr dt. And I'm trying to get this by itself, so divide both sides by 36 pi. So you'd end up with something like dr dt, okay, is, let's see, that'll reduce to 1/6 pi. The radius is increasing, so it makes sense that this is a positive number, and that is going to be in what? Cubic feet per minute. So feet cubed per minute is my label there. Okay. So that is the end of the review. Have a great night, guys. See you for the test.